हेलो, हेलो, हेलो।
गुड इवनिंग सर।
सो रहे थे क्या? सो गए थे क्या?
नहीं सर, थोड़ा ऐसा नेटवर्क इशू तो इसलिए ज्वाइन होने में लेट हो गया। सॉरी सर।
आज मैं एक्चुअली नया चैप्टर स्टार्ट करने वाला हूँ।
ओके सर।
आज केमिकल इक्विलिब्रियम स्टार्ट कर लेते हैं ना।
ठीक है सर।
तुम्हारा एग्जाम चल रहा है ना अभी? ये खत्म हो गया? तो केमिकल इक्विलिब्रियम के ना दो पार्ट है। केमिकल इक्विलिब्रियम के दो पार्ट होते हैं। एक तो नॉर्मल इक्विलिब्रियम और एक आयोनिक इक्विलिब्रियम। ठीक है, केमिकल इक्विलिब्रियम देखो, इक्विलिब्रियम क्या होता है कि जब भी हमारे पास कोई भी रिएक्शन होता है ना, जैसे इस टाइप का, ऐसे लिख रहा हूं मैं, ए प्लस बी बी इज गिविंग यू सी सी प्लस डी डी, मतलब ऐसा। सबसे पहले, अच्छा, ओके, see the equilibrium area. I'm representing this A plus BB is giving you CC plus DT. This is a form of chemical reaction. Like you have na CO2 plus H2 means C plus O2 is giving you CO2. Simple type. Here the coefficient what A is representing capital C, B is representing O2, capital C is representing CO2. D is not there. But here this small a represent this coefficient present 1. Small b represent this coefficient 1. In every reaction you must have seen there are different types of coefficient which are present here. Okay, like this. So this is a reaction. Now when we are talking about a reaction of this form, a reaction is said to be in equilibrium if AA plus BB is represented in this way. Like for example, N2 plus 3H2 is giving you 2NH3. This is the representation of an equilibrium. What is the meaning of this? The meaning is the reaction which is moving as much forward is moving backward in the same amount, with the same amount. The rate in which the reaction is moving forward is the same as the rate with which the reaction is moving backward. Getting it? And
यस सर।
so this is known as equilibrium. Usually when we deal with the reactions are like forward only, that I have represented in this way. But there are few reactions which are represented this way. What is the meaning? Means the quantity, when the equilibrium is existing, na, the quantity on the left side and quantity on the right side means it remains same, almost same, because the amount which is dissociating and moving to the right part is equal to the amount which is dissociating and moving to the left part. So basically, uh, amount got dissociated, but the same amount came back. So the amount remains same. Basically, the things remain same, nothing change, no changes there, like this. Now, when we are talking about equilibrium, I said rate of forward reaction must be equal to rate of backward reaction, that I said just now. Now, we should know how to calculate the rate first in a reaction. This is the required condition for equilibrium. Now, first we'll know in a reaction of type AA plus BB is giving us CC plus DD. How do we calculate the rate? The rate of a reaction is written as minus 1 by A d box A by dt. This box A, it represents concentration of A. So Kanishka, do you remember how do we represent the concentration in chemistry?
Sir, not exactly.
I forgot. Actually, I told you, see, in the basic chemistry class, basic concepts of chemistry, I told you, na, the concentration in a solution is represented by four quantities. Either you can show by using molarity or by normality. Molarity, normality, formality. Those things are there, na?
Yes, sir. Now I remember.
They are the means to represent the concentration in a solution. You will know the concentration only using that. Means when you are showing the what when we are talking about a concentration means it's like a viscosity, how thick a solution is or how thin the solution is. That in chemistry we measure by using molarity, normality, and all those things. So here this box A, this I am representing the this is known as the concentration of A. And similarly, B is known as the concentration of B. And it's nothing but molarity of the solution of A, molarity of the solution of B means we represent the concentration in terms of moles per liter. These are the units because number of moles per liter of solution is molarity, na? In moles
Yes.
per liter we represent. This is the basic formula of calculating the rate, minus 1 by A d by d, and this is also equal to 1 by C, d concentration of C by dt is equal to 1 by d concentration of d by dt. Basic differentiation and all you know already. This is
Yes,
how
sir.
we calculate the rate in a particular reaction.
Okay, so can you give one example like of using this formula?
I'll give
Yeah.
you that. See, if I've taken this above example only, and I have asked you to calculate the rate of a reaction, I'll give you one question you will understand. I've asked you to calculate the rate of this particular reaction. How you will find the rate of this particular reaction will be 1 minus 1 by 1 d concentration of N2 divided by dt is equal to minus 1 by 3 d concentration of H2 divided by dt, or it can be also written as 1 by 2 d concentration of NH3 divided by dt. Understood? This is how we frame a reaction.
So like we have to write the numbers which are given before like the elements. Like minus 1 upon 1 it's of N2 and then minus 1 upon 3 it's of H2. Then we have to come and then we have to compare both with it and the answer will come, right? Okay.
I'll give you an example. Wait, then you will understand better. Wait, I'll give you the question. It's a very common one. See, try this one. Question will be coming now.
सर क्वेश्चन नहीं आया.
अभी आएगा अभी.
ओके सर.
क्या कनिष्ठा आ रहा है?
No, sorry. I'm getting stuck. I'm doing it.
See, what we have to do here, na? Reaction is this: 2 and 2O5 giving this plus O2. Now, if we frame the rate equation, it will be rate is equal to minus 1 by 2 d N2O5 by dt
Okay.
is
Oh, I was writing wrong. I was writing like minus 1 upon 2 upon 8. That's why.
equal to 1 by
Oh,
4 d N2 by dt equal to 1 by 1 d O2 by d2. Now, what they have given, see, this when you are having this positive, na, this positive part is known as the rate of formation. This is rate of formation of NO2 and rate of formation of O2. Okay. This is because negative part is there here. This is known as rate of disappearance. Okay.
yes.
Now, what they have given, the rate of formation of NO2 is this. Means this value they have given. They have given dNO2 by dt is equal to 2.8 into 10 power minus 3. Calculate the rate of disappearance of dN2O5 by dt. So they are asking what is the value of minus dN2O5 by dt. Value they are asking. So here 1 by 2 into, in according to this reaction, this relation, minus 1 by 2 into minus dN2O5 by dt is equal to 1 by 4 into dNO2 by dt. But this value they have given dNO2 by dt, so I can write 1 by 4 into 2.8 into 10 power minus 3 and minus d N2O5 by dt will be equal to this multiplied with 2. So the answer will be 2 by 2, 4, 1.4 into 10 power minus 3. This is the rate of disappearance of N2O5. Okay.
Yes, sir.
One more question can you attempt? See this one.
Yes, sir. I will. Uh, yes. Sir. Okay.
क्या वो कनिष्का नहीं है या
सर सॉल्व कर रही हूँ।
बहुत टाइम लग गया, इतना तो ये मुश्किल नहीं है ये क्वेश्चन।
तो हो गया मेरा, वो थोड़ा सा कंफ्यूज हो गई थी बट समझ में आ गया, हो गया। आप आगे कंटिन्यू कर सकते
अच्छा देखो, इसका आंसर ये सॉल्यूशन में वैसे मैं बता देता हूँ पर कैसे होगा। यहाँ पे तुम इक्वेशन बनाओगे तो इसमें ये होगा, रेट इज इक्वल टू, तुम डायरेक्टली लिख सकते हो, रेट इज इक्वल टू -1/2, सॉरी +1/2 डी Cr2SO4 thrice by dt। अच्छा, एंड दिस इज इक्वल टू -1/3 dC2H6O डिवाइड बाई dt। इन दोनों की जरूरत है, बाकियों को लिखने की भी जरूरत, लिखना चाहो तो लिख दो, लेकिन लिखने की जरूरत है नहीं। इन्होंने रेट ऑफ अपीयरेंस मतलब ये दिया हुआ है, they have given this value dCr2SO4 thrice by dt, the value is 2.67। they are asking to get the rate of disappearance of C2H6O, means they are asking for minus d of C2H6O divided by dt, this value they are asking. Just you have to do this only, 3/2 into 2.67 will be equal to minus d of C2H6O divided by dt. Calculate this, 3 into 1.33, 3.9 and approximately 4. Your answer.
Yes, sir. This much.
Hmm.
Approx 3.99.
Acha, quickly give me the answer for this one now.
Okay, so solving in 3 minutes. I will not take the time. Sir, will be the answer the option A?
Uh,
Uh, excuse me, sir.
हाँ
सर इसका आंसर ऑप्शन नहीं होगा ना?
कोई चेक कर रहा हूँ मैं, एक मिनट.
ओके सर.
हाँ ठीक है, सही है, सही है.
ओके.
नहीं नहीं नहीं, इसका ऑप्शन ए नहीं है आंसर. नो 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 नो, नहीं
नहीं
कनिष्का,
सर.
इसका आंसर डी है.
ओहो, गलत कर दिया मैंने.
हाँ तो
मैं
पता नहीं,
फिर से करती हूँ.
पता नहीं कैसे
नहीं
गलत
तो
हो गया. देखो इजी सा है, तो ये देखो, वन इक्वेशन बनाओ, -1 dna by dt इज इक्वल टू -1/3 dnb by dt. इस तरह से लिखोगे तुम इसको, तो इज इक्वल टू -1/3/2 dnc by dt, like this you'll write. So this part will become -2/3 dnc by dt. Now there in the solution there is no coefficient of dna by dt. So what you'll do, you'll multiply it with -2 with the whole equation. Whole equation you'll multiply with -2. Okay, what it will become, dna by dt is equal to 2/3 dnb by dt, but these two things are there in option A or also in option D, is equal to 4/3 dnc by dt. Because 2 you are multiplying, get it removed. You have done silly mistake, I know.
यस सर.
Hmm. Acha. After this, see, we have come to know by now, for this reaction, we calculate rate using this method. Now, after this, the rate, the whole equation is written like this. See, this equation actually, this reaction it consists of two reactions. One is this forward one, Cc plus Dd, and the other is backward one. Okay, na? Means
यस
because
सर.
it's moving forward also like this, and it's moving backward also.
यस सर.
Now, if a reaction is given to us in this way, now how do this rate, we know how to calculate this rate equation that they say, this you will later learn in your class 12 chemical kinetics, you will learn there. This equation is written like this: rate is equal to the K forward reaction into concentration of A raised to power A into concentration of B raised to power B, like this. This is how, see, rate you calculate using the above one. The calculation is done using above one. But when they are asking about the rate equation of forward reaction, you just have to put this Kf is the rate constant for forward reaction. Okay, this is a proportionality constant. Actually, we write like this: rate is proportional to A,
ओके सर.
concentration of A raised to its coefficient into concentration of B raised to its coefficient, like that. Now, this rate is equal to Kf, with this proportionality constant is written Kf into A power A into B power B. Now, this is for forward. In the same way, this backward reaction, rate for backward will be equal to rate constant for backward reaction into concentration of C raised to power C into concentration of D raised to power D. This is how we frame the equation. This may be new to you, but later in the chemical kinetics, you will learn how to frame the equation like this.
Okay, sir.
Now, because we
Yes,
know,
sir.
in an equilibrium reaction, rate of forward reaction is equal to rate of backward reaction, that we have actually learnt initially. So these two equations, if we use these two equations, this is first one and this is second one. Let me write Kb also. Kb is the rate constant of for backward reaction. So the rate of forward is equal to rate of backward. So I will write Kf into A power A into B power B is equal to Kb into C power C into D power D. Now Kf by Kb, if you calculate, it will become C power C into D power D by A power A into B power B. This Kf by Kb is known as equilibrium constant, Kc.
So it's like a type of a formula, right?
This is the type of formula.
Okay.
I have just told you how do we derive that particular formula. Only when solving problems, you will need only this. When a reaction of this type is given to you, AA plus BB is in equilibrium, giving CC plus DD like that. So the
Yes, sir.
equilibrium constant is given to be concentration of C raised to power C, concentration of D raised to power D divided by concentration of A raised to power A into concentration of B raised to power B. This is how, this only you should
Okay, sir.
remember for problem solving. Okay.
Okay, sir.
That's
So
it.
it's like type of the derivation you have written above.
This is the derivation that I have shown.
Okay, like they can ask in the exam.
This
Or
can be asked in the examination.
okay, just a
In your
second. I
in your
will.
CB, in your
Is
CBSE,
the
they can ask. It's
is
important.
okay. So
But
can you scroll down? Like I'm writing.
okay, write it.
Just a second. I'm about to finish. Yes, so you were explaining something.
No, I was telling you one more derivation is there that is more important than this. This is the relation between
Oh,
Kp and Kc that I'll
which
discuss in the next
which
class.
can be? Okay, I will take the screenshot. I've just finished.
Don't worry, after the class I'll send you the PDF. That's not a problem. Let's end it now.
Okay, sir.